Welcome back to AI Unraveled, your weekly strategic briefing on the business impact of artificial intelligence. It is the first week of January 2026. If one of the world's best AI engineers feels left behind, where does that leave the rest of us? That is the question circulating Silicon Valley this week, after Andrej Karpathy admitted the programming profession is being dramatically refactored. We are also tracking a major acquisition. Meta has snapped up Manus AI, cementing its bet on autonomous agents. Meanwhile, a new report on AI Slop confirms what we have all suspected. Low-quality, generated video is taking over the internet, forcing platforms like Instagram to rethink their entire existence. But before we dive into the rundown, are you drowning in dense legal text? JamgaMind is the new audio intelligence platform that turns 100-page healthcare or energy mandates into 5-minute executive briefings. Whether you are navigating Bill C-27, Canada, or the CMS 0057F interoperability rule, USA, our AI agents decode the liability so you don't have to. Start your specialized audio briefing today at jamgamind.com. This podcast is created and produced by Etienne Newman, senior software engineer and passionate soccer dad from Canada. Now let's unravel the week.
Welcome to the Deep Dive, where we take that absolute fire hose of information in the tech world, all the articles, the research, the notes, and we try to boil it all down to the insights you actually need.
And we have a huge synthesis job today. We're looking at some data points that seem totally unrelated on the surface, but they all connect. We're talking about let's call it the paradoxical reality of the AI boom.
Right, across three big domains.
Exactly. It's this collision between, incredible speed on the tech side and these very real, very physical, very human limits.
That's it. So our mission today is to cut right through the hype and pull out what the industry is actually dealing with right now. We're going to hit the changing role of the programmer. Is code actually dead?
Gain the massive, almost Herculean infrastructure challenge, the AI power crunch.
And finally, the crisis in governance and quality, what we're calling the AI slop epidemic.
It really is the story of AI's supply and demand crashing into each other, told across software, steel, and society.
Okay, let's jump in. The software side. We keep seeing these headlines, the ones every few months. The end of computer programmers. And I know historically this just never pans out, but this time with LLMs, it feels different.
It does feel different. I mean, the public visibility, the scale of competence, it's a whole other level. But if you actually dig into the source material, this claim, the idea that new tech will kill programming jobs, it's ancient. It's almost cyclical.
How far back are we talking? Give us the context here.
We're talking all the way back to the 50s and 60s. With 3GLs like Fortran and COBOL, the critics were saying, okay, well, now that we have these high-level languages, we don't need the experts.
And it just kept happening.
Oh, yeah. Then you had the 4GLs and 5GLs in the 70s and 80s, which were supposed to let business users just write programs themselves. Then came WYSIWG editors like Visual Basic, even executable UML. All of them were hailed as the final nail in the programmer's coffin.
And the outcome was always the same.
Always. The outcome was always more programs being created, and because of that, more programmers needed to build and maintain them. The material we looked at calls this a $1.5 trillion a year example of Judden's paradox.
So making coding more efficient doesn't decrease the need for it. It just explodes the number of use cases, which demands more labor, not less.
Exactly.
But wait, I have to push back on that. Isn't that just a convenient historical pattern? I mean, if the next generation of LLMs gets, say, 99% reliable at writing code, doesn't the prediction finally come true?
And see, that's the key difference. This time, unlike before where the tech was reliable, the sources are pointing out that for most teams right now, LLM-generated code is a lose-lose.
A lose-lose? How?
It's a lose-lose for reliability and for maintainability. It just adds all this complexity without solving the actual hard part of the job.
Okay, so the bottleneck isn't writing the code itself. So what is the hard part that AI hasn't solved?
The hard part is bridging the gap between how humans think and how computers think. It's turning what the source calls the wooliness and ambiguity of our thinking, it's full of contradictions and nuance, into something that is logically precise, unambiguous.
In other words, the real challenge is knowing exactly what to ask for in the first place.
Precisely. The computer scientist Edgar Dijkstra predicted this almost 50 years ago. He said we would never program in natural languages like English because they're just too imprecise. The real work isn't spitting out Python tokens. It's defining the problem, the inputs, the outputs, all the edge cases.
Although the job is absolutely changing. I mean, we saw the tweet from Andrej Karpathy where he said he's never felt this much behind as a programmer. He said the whole profession is being dramatically refactored.
And that captures the feeling perfectly, doesn't it? It feels like you've been handed this powerful alien tool with no manual. The job isn't gone, it's just shifted. It's become this master prompter, this system architect. You have to master this whole new layer of abstraction agents, prompts, memory tools.
So if we accept that agents are here to stay, the sources suggest they force us to be much better engineers. Like, they're great assistants, but you need these mandatory guardrails. One developer called them a Roomba that rolls over dog poop.
It's a great analogy. They're not good at cleaning up their messes. So what top teams are doing is taking these best practices that were always kind of aspirational and making them non-negotiable prerequisites. You have to shrink the search space of what the AI can even do.
Okay, give us the big one, the one that sounds almost impossible.
100% code coverage.
Wow. Okay, that is a big one.
Yeah.
I mean, most teams aim for what, 90, 95%? Getting that last few percent is famously brutal. How are teams actually doing that?
It's all about eliminating ambiguity. See, at 95%, humans are always arguing about what's in the other 5% that's important enough to test. But when you mandate 100%, that whole argument it vanishes.
So if a line of code isn't covered, it's a binary choice.
It's a binary choice. Either the agent just broke the rules, or you don't actually need that line of code and you should delete it.
So the coverage report stops being a guideline and becomes a simple black and white to-do list. It forces the agent to prove, with code, that it understands every single line.
Yes, you're externalizing its thinking and demanding proof.
Okay, so that's testing. What about the code base itself? How do you structure it so an AI can even read it effectively?
That's rule number 2, thoughtful namespaces and small files. Agents navigate your code using the file system. You have to think of it like a library. The better the Dewey Decimal System, the more precise your labels, the easier it is for the AI to find the right book.
So a generic name like .utilshelper2ds is terrible.
It's awful. But something like .billinginvoicescompute.ts is perfect. You use descriptive names, and critically, you keep files small. LLMs have context windows, and they'll often truncate or summarize big files. Small files mean the LLM loads the full context every time.
And what about data integrity? We're dealing with statistical models, not logical ones. How do you stop them from just making up data that breaks everything?
That leads to the third, and maybe the most powerful rule. End-to-end types, using typed languages like TypeScript or specifications like OpenAPI for your APIs and Keisli for your database.
Okay, break that down for someone who's not a daily coder. Why are types so important here?
Sure. So if a model sees a generic piece of data, it has to guess what it is and what's safe to do with it. But if it sees a specific type, like, say, signed webhook payload, the type system is screaming at it, this data is secure, do not touch the signature.
So types just eliminate whole categories of mistakes the agent could make.
By orders of magnitude, the system literally won't even compile if the agent tries to pass a string where a number should be. It shrinks the universe of possible actions.
And the final piece is speed. You can have all these rules, but if it's slow, no one will use it.
Right. You need fast, ephemeral, concurrent dev environments. Those checks, like running NPM tests, have to be cheap and fast. If your test suite takes 20 minutes, the feedback loop is broken. The best teams are getting like 10,000 assertions done in about a minute.
Why is that speed so critical?
It keeps the agent on a really short leash. You make a tiny change, you check it, you fix it, repeat all in seconds. And the environments have to be ephemeral, fully automated. An agent needs to be able to destroy and rebuild its entire world instantly with one command.
It's fascinating. Yeah. To use AI better, you have to become a more rigorous engineer. And if that leads to more code, well, that code has to run somewhere. Let's pivot from the software to the physical world, the infrastructure. This is where it gets really crazy. How bad is the power crunch?
The urgency it's existential. This is where the digital hits concrete. The forecast for U.S. AI power demand is projected to just skyrocket, from around 3 gigawatts in 2023 to over 28 gigawatts by 2026.
28 gigawatts. Just for perspective, 30 gigawatts is roughly the entire power capacity of a country like, say, Ireland or Denmark.
Yeah.
It's a stunning amount of growth to ask for in just 3 years.
And the grid is it's completely overwhelmed. Take Texas. It's the epicenter for this stuff. They have tens of gigawatts of data center requests pouring in, but over the last year, they've only managed to approve and connect barely a single gigawatt. The whole system is seizing up.
Why? Is it just red tape?
It's partly that, and partly that big transmission upgrades, the huge power lines, take 3 to 5 years to build. AI companies cannot wait 5 years.
No, because speed is the moat.
Yeah,
Delaying by 6 months could be a billion-dollar mistake.
billions. An AI cloud can generate $10 to $12 billion per gigawatt per year. Getting a big data center online 6 months early is worth a fortune. This economic pressure just dwarfs the grid's problems.
Which has led to this new playbook,
Yeah.
BYOG, bring your own generation. Essentially, just give up on the grid for now and build your own power plant.
Exactly. XAI really pioneered this. They just bypassed the grid entirely. They used truck-mounted gas turbines to get their 100,000 GPU cluster online in just 4 months.
And others are following.
Oh yeah, fast. OpenAI and Oracle put in one of the biggest orders ever for on-site power. A massive 2.3 gigawatt gas plant in Texas.
And this demand must be creating a boom in some unexpected places. Who's actually building these things?
It's the big global industrial players. A company like Wärtsilä, who historically made giant engines for ships, they're now adapting those same engines for data centers. They've signed 800 megawatts of contracts, even Boom Supersonic,
The jet company.
the jet company. They announced a 1.2 gigawatt turbine contract. They see the profits from selling power as extra funding for their supersonic jet R&D.
Funding a Mach 2 jet by powering AI. That says everything about this market. Okay, so let's get into the tech. What are the three main types of BYOG equipment they're using? Let's start with the jet engines.
Right, those are the aeroderivatives, or IGT's industrial gas turbines. Literally a jet engine bolted to the ground. Their big advantage is speed. You can deploy them in weeks, and they ramp up to full power in like 5 to 10 minutes.
So they're great for backup power later on. What's the downside?
The downside is you can't get them. The lead times are huge, like 18 to 36 months. There are massive supply chain bottlenecks for the specialized parts, like the monocrystalline nickel alloys for the turbine blades.
Okay, what's the second type, the ICEs?
Reciprocating internal combustion engines. So think of just a really, really big car engine, piston-driven. They're great because they're efficient even when they're not running at full blast. The problem is just scale. To get a 2 gigawatt system, you might need 500 smaller 5 megawatt units.
500. For one data center. That sounds like a maintenance nightmare.
It's a huge operational lift. You're talking about scheduling 40 engine services a week, oil changes, spark plugs, the works. It requires a massive operational team that these tech companies just don't have.
And the third option, the one that avoids burning stuff altogether, the fuel cells.
Yeah, we're talking about solid oxide fuel cells, or SOFCs.
Yeah.
Bloom Energy is the big name here. They run on natural gas, but it's a chemical reaction, not combustion. Their killer advantage is permitting.
Because there's no air pollution.
Right. No material air pollution besides CO2, so the EPA permitting process is way faster and smoother. Deployment is also quick.
So what's the catch?
The catch is they're thousands of dollars per kilowatt, way more than turbines, and they have a really slow ramp rate. They're what you'd call a base load generator. You turn them on, and they just run at peak output constantly.
So if you go off-grid, how do you even try to match the reliability of the actual grid? I mean, it's up 99.93% of the time.
You have to massively overbuild for redundancy. To get that kind of reliability, you need an N+1 or even an N+1+1 setup. There's a stark example in the source material. For a 1.4 gigawatt data center, you might need 2.3 gigawatts of generation capacity. That's a 64% overbuild.
And AI workloads are so spiky, that must be terrible for power stability.
It's awful for stability. These training loads cause these huge megawatt scale surges and dips. It's like slamming the accelerator on a giant engine, then taking your foot off over and over. Without inertia in the system, the power frequency just wobbles and the whole data center can crash.
So what do you do to add that inertia back?
You need auxiliary systems, things like synchronous condensers, flywheels, or, and this is very common now, battery energy storage systems, BESS, like the Tesla Megapacks that XAI is using. The batteries absorb those shocks and keep the frequency stable.
This incredible investment in power is creating this massive wave of computational output, which leads us right into our third segment, the quality and governance crisis. So all that power we just talked about is being used to produce content where a huge chunk is literally being called brain rot. But let's start with something more serious, AI-written police reports.
This is a classic governance problem, and it goes right to the heart of due process. The issue is with tools like Axon's Draft 1, which comes with their body cams. The tools themselves are unproven, but the real failure is that they are untransparent by design.
Untransparent by design. What does that actually mean if you're, a citizen in a courtroom?
It means Axon designed the tool to erase the initial AI draft as soon as the officer submits the final report. This is a huge accountability black hole. It means if there's a contradiction in court, an officer can just say, oh, the AI wrote that, and there's no first draft, no audit trail to challenge them.
Wow. Okay, so what has the policy response been to that?
Pretty swift and, in some places, effective. King County in Washington just barred AI narratives completely, and states like California and Utah have passed bills that require disclosure if AI was used.
And California went further, right?
Yeah, they did. They banned vendors from selling police data, and crucially, they mandated that the first draft has to be retained for auditing. That retention rule is the key to preserving due process.
Okay, now let's zoom out to the whole internet. This flood of low-quality content. It's a global issue.
Yeah.
We have these new terms now, AI slop and brain rot.
Right. AI slop is just that careless, low-quality stuff churned out to get views. Brain rot is a bit more insidious. It's that compulsive, nonsensical video content designed to just capture your attention and corrode your focus through endless scrolling.
And how much of this stuff is actually out there on, say, YouTube Shorts?
An analysis by Capwing found it's saturated. For a new user, a full 33% of the first 500 shorts they were shown was classified as brain rot, 1 in every 3 videos.
1 in 3. That's incredible. Is this a regional thing?
No, it's a massive global business. AI's slop channels are huge everywhere. Spain has the most subscribers. South Korea has the most views. There's an Indian channel, Bandar Apna Dust, that makes realistic monkey videos.
Mm-hmm.
It has the highest estimated annual earnings at $4.25 million.
So there's a huge financial incentive to just create this noise.
A massive incentive. And the social crisis here is that this content preys on the laziest areas of our mental faculties. It contributes to the illusory truth effect. The more you see a claim, even a fake one, the more you believe it. It's drowning out high-quality signal with low-quality noise.
Which just makes trust and reliable information that much more valuable. Okay, before we wrap, there was one big acquisition that kind of ties back to where we started on the software side.
Right, Meta acquiring Manus. Manus was all about general AI agents, that autonomous execution layer we were talking about, the thing that forces you to write better code. The acquisition is just a huge validation of this industry-wide focus on building that execution layer, turning the LLM from a prediction machine into a doer.
To a capable programmer.
Exactly. I mean, Manus had already processed 147 trillion tokens. They'd powered over 80 million virtual computers. They know how to do this at scale.
Okay, so let's try and tie this all together, these extraordinary tensions. A programmer's job isn't vanishing, it's getting harder, demanding higher standards. At the same time, the demand for AI compute is so far beyond the grid's capacity that it's creating this multi-billion-dollar race to build private power plants with jet engines. And then the output from all this is challenging everything from our justice system to the basic quality of information online.
It's that collision. AI's unbounded digital demand hitting hard physical supply-side reality. And the most fascinating part of that is with the power infrastructure. The gas turbine manufacturers are hesitant. They're not ramping up to meet this insane demand, even with all the money on the table. They have what the source material calls institutional PTSD.
PTSD.
From 2 huge boom and bust cycles in the last 30 years. The Y2K and dot-com bust, and then the big decline in traditional power plant orders from 2017 to 2022. They saw billion-dollar orders just evaporate overnight. So they are very, very reluctant to build new factories or invest in those fragile supply chains for things like the special nickel alloys.
So even though AI companies are waving billions of dollars around demanding 28 gigawatts of power, the engine builders themselves are holding back. They're constraining the supply of the one thing AI needs most.
Exactly. And that raises this really profound question for you, the listener, to think about. We are watching digital ambition slam into the wall of physical reality. What happens to the speed, to the entire trajectory of the AI race if the engineers building the power plants remain skeptical that this boom is even real?
A fascinating and complicated thought to end on. The most futuristic race in the world, held back by very human skepticism and the physics of 300-ton steel turbines. Thank you for joining us on the Deep Dive. We encourage you to keep exploring these complex topics.
That wraps up our briefing for the first week of 2026. The signal for this week is refactoring. The profession of coding is being refactored by agents like Manus and Codex. The infrastructure of the internet is being refactored by AI Slop and new architectures from DeepSeek. And the physical grid itself is being refactored to power the next generation of data centers. The systems we built yesterday are already being rewritten today. Before we go, a reminder for the leaders listening. Are you drowning in dense legal text? JamGamind is the new audio intelligence platform that turns 100-page healthcare or energy mandates into 5-minute executive briefings. Whether you are navigating Bill C-27 Canada or the CMS 0057F Interoperability Rule USA, our AI agents decode the liability so you don't have to. Start your specialized audio briefing today at jamgamind.com. This podcast is created and produced by Etienne Newman, senior software engineer and passionate soccer dad from Canada. Please subscribe and share. Until next week, keep unraveling the future.